there's more data, more decision making to be done, more processing power is needed. One of the biggest issue is the power consumption. We want to be sustainable. We want to provide more sustainable solutions to the market, right? In that area, we're seeing a lot of innovation on the semiconductor side to provide more power efficient solutions to enable high data manipulation, more quicker decision making as well.
Welcome to FNet Silica's We Talk IoT. We'll chat with innovators, experts, and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth Haydock. Today, I'm thrilled to have Mohammed Dogar, Vice President of Global Business Development and Head of AI Center of Excellence for Renesas Electronics on the show. In this episode, we'll explore how the AI Center of Excellence at Renesas operates. We will unravel some common misconceptions about AI in the IoT space and discuss opportunities in real-time analytics. We will also delve into how technology is evolving in areas like voice, vision, and audio analytics, and how engineers can navigate this AI-centric landscape despite not being data scientists. So let's get started. Welcome, Mohammed. How are you?
Yes, thank you. Thank you. Really pleased to be here. Exciting times in the world of embedded and, of course, AI. I'm Mohammed Dogar, as you introduced. I head up the global business development for our embedded processing portfolio. And I also head up the AI Center of Excellence for Renesas as well, where lots of exciting things happening, in the embedded space. I think the world has significantly changed around us, really. If you think about it, the last decade, right, as the connected devices in the so-called IoT arena proliferated and their capability expanded, they grew a need for real-time decision-making, independent of cloud or connectivity in some cases. So where, we were used to rely on a big cloud backup and a lot of resources utilized. Now, in this whole connected IoT world, and what we now call is AIoT world, the decision has to be made real time in the device. And this move to the distributed architecture is driven by the transition of computational capacity from the cloud to edge. So that's really given a big boost to the adoption of AI. And really in our world, how AI can solve the problems, real-time problems, real-world problems in the space that we operate. Ultimately, what we are trying to do at Renesas is to support that. And as you mentioned, there are challenges in terms of the readiness on the engineering side and solution side, but exciting times and big opportunities in front of us.
Yeah, I'm supposed you are quite busy with all the hype that has been stirred up in 2023 with everything artificial intelligence. Could you give us a quick overview of what it is you do at the AI Center of Excellence and what are your primary goals and focus areas?
Yeah, absolutely. So what's driving us is if you think about the data that's created by the so-called endpoint or in the whole AIoT context, is expected to go as staggering, something like 85%. I was looking at some numbers by a market research company recently, and they're talking about that this data generated by the IoT devices could reach up to 80 zettabytes by 2025. And by the way, did you know how many zeros in zeta is? 21. So it's massive. And what we was looking at from Renesas' point of view is that we work across the industry in terms of, industrial automation, consumer electronics, infrastructures, enterprise. And what we're seeing is this real intelligence being added to the endpoint devices on sensors in the factory floor, on smart buildings. How do we address that? And at the same time, before I dive into what we do, I think it's important to understand there's a technology convergence happening and why timing is right now for the AI adoption, because we've been hearing about IoT for the last several years and it took a little time, but we feel that IoT, AI and 5G is somehow maturing at the same time, creating this platform to be able to communicate, to be able to transfer high amounts of data at a high speed, real-time communication. I talk about decentralization of intelligence. We are not relying so much on the cloud backup, devices becoming much more independent. So this whole approach is creating a new design mindset as well. So that's kind of what's driving from the market point of view. Now, to answer your specific question, what we see is if you think about the AI world, there are two types. There is what we call is the predictive maintenance, and the second one, which is basically content and AI, right? So what you see on ChatGPT, etc., where new types of content is being generated through AI. But what we talk about at Renesas is, of course, taking advantage of this new content generation, but more importantly, the predictive maintenance side of things, where we can really help our customers in the industrial field, in the consumer, in the healthcare, in the enterprise side to add value to the applications. Now, for our Center of Excellence, we focus on three key technologies. One is the Vision AI, which I think everybody talks about. What can we do through whether security-based system, recognizing somebody, facial recognition and making a check and enable access to machine vision in terms of what's happening on the factory floors from quality control to manufacturing process optimization. Then the second one we focus on is, of course, voice. Certainly the COVID has changed the world significantly. We want to operate these devices through simple voice command. And the third one, which I'm particularly very excited about, is what we call is real-time analytics. Some people call it time series. This is where what's really going to solve the problem for embedded devices. So these are three core technologies that we focus on to help our customers. And I can give more detail later on in the conversation.
Exciting. What you said with the convergence of AI and IoT and major technologies all developing and emerge, basically scaling at the same time, it's a lot for your customers and engineers to wrap your head around, right? In your experience, are there also common misconceptions about AI in embedded systems?
Excellent question, Ruth. As released, there's a lot of hype, yeah? We need to basically move away from the noise and see where can AI really add value. Now, before we go into that, there are a lot of misconceptions. People feel that, AI can be just added as an after feature, right? AI, just like security, you have to design your system from ground up, to be able to add value and add more services on top. And other misconception is that, maybe it's just so seamlessly easy that anybody or our typical embedded developers can develop AI-based solutions. Now, realistically, what I think was going to accelerate is we enable those embedded engineers who are not data scientists, right? We are, so on one side, of course, we rely on, AI to say it's like whatever you put in is the best you get out, right? It all depends on the data, but there's so much data there. So we need tools which can actually help us label the data, help us optimize the data. And remember, these devices where we want the AI to operate 90% of the time are very low resources. They don't have so much memory. They don't have too much CPU consumption. We need to work on a small set of data. So we need tools to help our developers. And then the developers themselves need tools to be able to, create a solution that solves a certain problem. So yes, the misconception that it can just be added and everything can be done in tools, but it's kind of a bit of both. So we need tools to help us on the front end. And then we need developers to actually develop using, their existing mindset and their expertise. That's the key to really, if you really want to accelerate this.
I like how you said that engineers are not data scientists. How would you enable them to implement AI in their projects?
Excellent. So what we have done, if I just focus on, for example, on real-time analytics, and what I mean by real-time analytics is think about an application where you have lots of sensors these days in our systems. It could be a building or a factory or some sort. We want to be able to read the data from those sensors and you make some sort of decision based on any anomalies that you want to solve. What we have done, we acquired a company called Reality AI about 18 months ago, which is basically works on sensor-based data. We can work on any high frequency sensor data. This could be voice, could be pressure, could be any type of sensor data that's out there. And we have the tool where the customer do not have to be an AI or data scientist to be able to take that data and then define what kind of accuracy you want to predict. So for example, let me give you an example. We recently solved a problem for a major PV inverter customer who developed solar panels and, green energy solutions. And one of the problem it has is there's a large number of PV fire accidents, which is normally caused by DC arc due to poor contact of devices or aging of damaged cables. So this customer is using this so-called AFCI-based solution to prevent that. Now, they had an existing solution for a residential solar inverter. They were only able to detect the faults with a 50% accuracy. And this is a real use case problem. It's not a fancy, vision or something else. It's a real way it could be a safety issue, right? So what we did was we deployed the Reality AI tools. We analyzed the data that customers provided us. With the Reality AI tools, we can work on a very small sets of data, and the tool itself can tell you how much accuracy you want and what kind of memory, power consumption, or the CPU resources you need. Now, this was running on a microcontroller, which is running at 100 megahertz. And finally, we develop a model, which is basically almost near perfect cross-validation using SDFS. So it's a spectrogram feature over a 8 microsecond data segment. And that took us some sort of 8K of RAM, 23K of flash, and we deployed this. And we were reaching over 95% accuracy. So didn't add any new hardware. We did not change the configuration. We basically used their data to be able to detect at the certain crossover frequency, that the system can detect if there's a fire and how to prevent that. So before it's emerging. So this is really, a noise in the market. So there are real world problems that AI can solve. So through our Reality AI tools, you can create the model, and then we have now developed a system where you can actually transfer the data almost like a C file into the embedded development environment and create your project based on C code, where you have this model now built into your overall solution.
It's terrific. So basically, for the client you just described, the opportunities, of course, much better results with less hardware, I guess.
Actually, no external hardware at all. So we use basically obviously the current and voltage and different variation in the sensor data to be able to detect that if there's a fire to be started on the inverter side.
What other opportunities, particular in this area of real-time analytics, do you see for your customers? Or maybe it's also, if you want to share some more use cases, that'd be also a great opportunity to discuss.
Absolutely, Ruth. I think we are here to solve problem for our customers and really add value. One of the typical problem you see in the world is we have lots of motors in the world, whether it's a home appliance, an air con, whether it's a washing machine, whether it's a pumping, the water in the pumping station. So motors are everywhere in our world. And one of the biggest problem the motor has is the unbalanced condition. So one of the problem we solve for a customer is a major home appliance manufacturer, and particularly for a washer, which was using some typically you have in your house. What happens if think about this washing machine in your kitchen, when you spinning that washing machine, it can go up to 22,000 RPM. It's a very high speed. If we cannot control that speed, actually can get out of balance and basically hurt someone or damage something. And one of the problem with the washer is the unbalanced, right? You can put a lots of load in terms of clothes or not enough loads, and you want to make sure that it's spinning in a balanced way and it's not creating lots of vibration or it's not damaging your fabric or something like that. Currently, this customer was using an accelerometer, which cost them about $4 per board, which actually looks for this unbalanced condition, right? We went in and we, again, using the Reality AI software, we took the data in terms of looking at different current and voltage signatures and the variation in that. And we developed a model, and we can, almost 99% accuracy, where just through software, we can detect if the washer is out of balance, right? And the beauty of this was, customer did not add a new microcontroller. It was using our Renesas RA6T1 microcontroller, adding any additional hardware. Actually, they removed this. They saved $4 per device, and they were able to add, this very high accurate unbalanced load detection solution. So now this is very close to what we see in our homes. So a real problem, cost effective, and AI solving the problem, safety as well as cost, and providing a high optimized solution.
We will take a short break. Stay with us. We will be hearing from our guests very shortly. This podcast is brought to you by AFNet Silica, the engineers of evolution. We help you bring secure, intelligent, and connected products to market. If you want to learn more about us, we have put information and links in this episode's show notes, and you can also connect with us on LinkedIn or avnet-silica.com. That's avnet-silica.com. Are there other use cases you would like to share?
Yeah, I think honestly, the applications are endless, right? We work in a very diverse factor, whether it's an industrial application, a power tool. I talk about the appliances, or even automotive. We provide solutions, and I'll talk about that a bit later on. But in one of the other one is interesting one is, in a lot of things these days are battery powered, right? Whether it's your kitchen appliances, whether it's your power tools to do some work on the buildings, whether it's your lawnmower, So one of the things is, how do we make sure, one of the big problem with the battery system is, how do we stop the battery from discharging when it overheats, right? That's a typical problem. So what we did was, the problem basically is that to predict the temperature difference of the components in the battery using, we're using some least amount of sensors. So we're seeing, battery pack has different material. And we did that. Basically, what's critical is, in the thermal model, is to help protect, at the same time, get an accurate current measurement on this as well, using, shunt or resistance or heat value. Customer traditionally was using a model with MATLAB, but it wasn't providing enough accuracy. So in this case, they were using a very low-end 16-bit RL78 microcontroller. And what we did was, we basically were able to predict the thermal temperature difference within, and almost achieving, there is a measurement criteria called R squared at, equal to 0.995, with the predictive value within 4% of the actual difference. And as a result, we were able to provide consistent across multiple battery packs. And then the whole solution did not add any additional hardware. And the beauty of this was, we were able to deliver this software, this model, only using 148 bytes and 5K of flash. And then the whole thing, took a very small percentage, and we were able to, stop the batteries discharging. So this solution can be applied to many, many other applications. So really, it's the use cases are absolutely endless. Ultimately, I think, for AI to really accelerate in terms of adoption, we have to solve the customer's problem by using their existing hardware. And that's what Renesas offers. With our Reality AI software, you can create an AI model, very highly optimized, using a very small set of data, and run this alongside your application code, but add the AI functionality, like some of the example I've given.
Excellent point, yeah. Adoption really is key, right? Especially with a technology like AI that is evolving so fast and rapidly.
Yeah, absolutely. And I think the other point is, how do we enable, as you mentioned at the opening of your discussion, is that how do we enable those masses of embedded engineers who's not data scientists? So here again comes that, there has to be tools that can solve the problem of, data optimization, because the problem is too much data out there. And how do we use enough data? So think about all the application examples I've given you. They are not connected to the internet all the time. They don't have a cloud backup. They're running on some sort of small microcontrollers with not enough performance, and they have to make a decision real time. So they don't have the luxury to go back and do the training of the model on the cloud and come back and make a decision. So therefore, I think we need to enable those engineers through that. So our solution is built on signal processing. So engineers, the embedded engineers, can very easily understand it's mathematics, basically. It's arithmetics, right? And that's where we need to bring that knowledge down to the embedded engineer and accelerate this adoption. So take the data optimization on one side and the deployment, and give the developers chance to develop what they know best and give them the tools to be able to create highly optimized models.
Excellent point. At the beginning of our discussion, you also mentioned something like AI segmentation. How is this evolving in the embedded space, and are there any specific trends or patterns that you have observed?
Yeah, so I think largely, as I said, you can, in our world of embedded world, you can look at these AI in three ways, as I said: vision, voice, and real-time analytics. Vision has started and it seems quite established in, let's say, in the access control, security system, personal recognition, that kind of stuff. And now we're seeing that adoption more in the machine vision space. So, for example, we have solutions with our third-party partners where we can give a solution to our customers on a manufacturing line. So let's say they are manufacturing bolts or pumps, right? And they can actually monitor the quality, the dimensions, and whatever the criteria, the QA criteria is, really accelerate by using vision AI to detect the products coming off the production line and really accelerate that testing and final QA process. So I think vision is coming more now in those, real machine vision application, industrial automation, this kind of stuff. Of course, still there are a lot of work to be done on access control and detecting images and that kind of stuff. One other thing we're seeing now is that, you can develop a model, but then, things can change in the field. We want to be able to, what we call is the, training in the field, right? So we're also developing technologies where as the more data is coming from the field through the sensor and others, the model is able to adopt and basically reconfigure in terms of, what we call is transfer learning, right? So you're learning new things. It's like, think about us as humans, right? As we growing old, we're learning new things, and our ability to process the data and make decisions changes. So transfer learning is also being accelerating as well and coming in the vision, voice, and real-time analytics space as well. I'm seeing voice, if you look at that, voice command, but I'm looking now, the major trends are natural language understanding. So before you had like Siri or other devices at home where you can give a specific command and it says, go tell me what the temperature is, and it tells you, that's fine. But now we need these devices to work on understand a natural, as you and I talking, to be able to use that natural language and then process that whatever you want to do. So for example, we have recently released a solution based on our RA8, which is a new CM85 based microcontroller where we can actually do natural language understanding for a number of applications. We're providing the software, the kind of reference design as well. So that's also coming in that voice side. And then in the real-time analytics, which we talked a lot in terms of use cases, what I'm seeing is that a lot more optimization, right? Also integration of security with the AI, and also multi-models. We're seeing a lot of applications where you think about an access control system, for example, at a building or a lab or somewhere, you're speaking, so they can actually have a model to recognize your voice. At the same time, they can do the facial recognition, right? And also perhaps have some sort of sensors on the door, which you take in direct sensor input. So you have 2 or 3 different types of model running on one device. So multi-model AI is also on the rise in the embedded space as well. And this is where, again, Reality AI from Renesas Electronics, we can really use to help our customers to develop optimized AI models for a number of applications across industrial, automotive, healthcare, enterprise, infrastructure, and large number of other applications as well.
Where do you see the future of AI and IoT heading? Do you have particular new technologies and innovations that excite you the most?
So I think it's threefold, really. One is that there's more data, more decision making to be done, more processing power is needed. One of the biggest issue is the power consumption. We want to be sustainable. We want to provide more sustainable solutions to the market, right? In that area, we're seeing a lot of innovation on the semiconductor side to provide more power efficient solutions to enable high data manipulation, more quicker decision making as well. So there's a lot of innovation going on that side. Also, in terms of the performance and features, security interfacing into the AI space, as I mentioned before. And finally, I think more tools that actually can bridge the gap between embedded space and the AI space. Now think about today, AI domain and the embedded domain is kind of operating separately, right? You have some sort of software tool on a PC, you put some data in, you create a model, and then you have no physical connection onto the embedded side, right? Because that's a separate embedded tool, right? What we are doing is to working now where, almost bringing a bridge between the embedded space and the AI space to be able to transfer the model seamlessly into the embedded space. So bringing the embedded and AI world together using more optimized development tools is also an innovation I'm seeing in that space. And, you mentioned about Center of Excellence. So we have a Renesas AI Center of Excellence based out of our Maryland offices in the US. And we're doing a lot of research and work on how we can actually do more optimized AI solutions for embedded applications. We're looking at more neural network manipulation. We're adding a lot of AI accelerators in hardware, within our devices to work with more workload. So our Renesas AI Center of Excellence looking at, voice, vision, and real-time analytics, and working on a lot of new technologies yet to come in the future.
And what advice would you give to engineers or developers that now want to delve into AI and IoT, and especially in the context of real-time analytics?
Yeah, I think my advice is very simple. I think we want you to focus on your expertise, what you know, right? And please use the tools to help you accelerate your development. And ultimately, focus on what problem you're trying to solve, right? And how you can make it. And then, use the tools to help you, create those optimized models. And ultimately, the world is evolving. We're all learning, we all upgrading our knowledge. And I think it's a great opportunity for our embedded engineers to also, go up the value chain and look at, how data is solving problems, how we can add value to our applications. So I think it's an opportunity for all, but certainly for our embedded engineers to really scale up their knowledge on the technology of machine learning and AI, but ultimately focus on what problem it solves. And then there's tools and solutions out there that can help you achieve that.
Terrific. Thank you so much for your time, Mohammed. It was really interesting talking to you. Thank you very much for being on the show.
Thank you, Ruth. It's my pleasure. Nice to talk to you, and let's keep in touch.
This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.